Hi everybody, welcome to this fourth lecture. In this lecture we're going to examine how we can start rendering all the elements that we need in order to make like a composed image such as this. So for preparing the materials that we need that we have used in the previous lecture. So if we look over here, we're going to deal with multiple things. We're going to deal with render pulses, render layers, and contribution maps. So we're going to deal with render pulses, render layers, and contribution maps. Now, before we get started with this, the first thing that we're going to do is we're going to examine a little bit how we can control the rendering in some more aspects. So what I want you to do right now is to make sure that you have this scene opened, which is from the home assignment lecture 2. So it's the first one, or you can have something else to your own liking, but if you have something like this by default, it could be rather easy. So first thing that we're going to examine is some aspects about the rendering, and especially if we go to mental ray and we watch the command tab, some of the things that we're going to do we can find right over here. Now if we check the first tab, which is set to color management, now here you have like the ability to change whether you want to have like all kinds of color mappings that's going to change the original color to some other settings. Now usually this is something you want to leave alone, especially in these days. It was very useful in the past when they had like special compression formats in which they want to store as much data as possible depending on the region where you are of the image. So we're gonna switch this off. This is actually something you don't need to use that much. Now we're going to talk about the file output. Now there are different kinds of file outputs that we have. We have like Maya EFF, Wavefront, RLA, all these kind of things. But the one we're specifically going to focus on is OpenEXR. And OpenEXR is a deep image format. And the difference, or what is special about the deep image format, is the fact that it can contain multiple layers. So meaning that instead of just having RGB and alpha, that you can also apply whatever kind of channel that you like. So you can have by default RGB alpha, but also you can add Z buffers, you can add whatever name or whatever layer name that you think of. So it can be diffuse passes, can be specular passes. All of those things can be stored just within one image. So it's not containing only like 4 layers, it can contain as many as you like. So this is extremely flexible, and it's actually the standard image format being used all over the CG industry right now. Now the image compression, we're going to leave it for what it is. The naming prefix is also something I'm going to leave for now. This will be more clear the further we go into the project. I will touch this and talk what this is all about. As well as the frame, the naming extension, this is also something we can leave for now, or no, we have to adjust it because we're going to make like a new rendering. So what we're going to do is over here set the frame animation extension. So right now we just have like the name of the scene. We can see over here in preview the file name on top, and we see the path. So if we go over here, we can go to watch the image, we can watch over here the name underscore extension. So let's do this over here. So once you do this, you see another preview of the file name. We see like home assignment L2 underscore 1 EXR to home assignment L2 underscore 10 EXR. Now this is not going to work very well if you're going to have like if you want to have like proper ordering of these files. So you have to make sure that you add some frame padding. So once you do this, you see that zeros are being added so that you have like a complete set of values, which makes the ordering much more convenient. Alright, the frame range, since we're not going to deal with animations right now, we're going to set the start frame and the end frame just to 1. We don't have to renumber any frames or anything. The render camera is going to be what it is. Alpha masking is fine. For the rest, there are like presets for the pixel formats, so you can have like HD or whatever that seems to be necessary. Here we took like a custom settings over here. Here we have like pixel aspect ratio. Well, this is also something which is for most devices obsolete, since that most of the pixel systems do have like square pixel ratios. This was especially used in the past when you had like this old format which is called PAL, what we can see over here, and in this PAL format you were able to stretch to widescreen, etc., and therefore you had to adjust these kind of things. So we're gonna leave this for what it is right now. Now, the other thing that we're going to add is over here, let's go to quality, is we're going to change over here the frame buffer. And that's something we have to examine. Now, right here we see like the data type is set to RGBA 4 times 8-bit. So this means like 256 colors per channel. And 256 colors per channel, it might seem like a lot, but actually it's not. It's like very limited. Now, in order to make sure that this will become like very visible what the problem is going to be, we're going to remove over here the dithering as well. So this is going to make it very clear. So now we have like our settings properly set to have like good rendering. Just perhaps one thing that we will change over here. If we see over here we have the anti-aliasing quality. Well, it's set to 0, so we don't have like a box filter or anything. So this should just be fine. So okay, we can go with this one. Right. So you can hide this panel right now. Now, if you want to render an OpenEXR, something important to know: once you render over here, you can't save from the render view OpenEXR. So if you go save image, you're going to see the available image formats doesn't include OpenEXR. So that's something we really need to change. So close this. The way how you can render those is by using batch rendering. Now, there are a few things that are important before you do your batch rendering. You really want to know where the image is going to be saved. So in order to do so, what you should do is make sure that you have like a project properly set. So go to set project, and in this case I'm going to make sure that my renders are going to be placed properly. NHTV, courses, 3D rendering, lecture 4, right now 2013, and I use this one. So I'm just going to select where I want to save all these things. So it's in this directory. I'm gonna set this. So right now, if you made sure that you have the project set, you go to the command tab, you see the path is being set completely exactly to that project setting. So now you will know where to find it. You will find them in that project under images. Okay, so now we're ready to render batch render the whole thing. So it's going to render. We see over here in the display when you do batch rendering what it's going to do and where it is at the point. Okay, so we're ready right now. Let's go to composite. First thing we need to do is to create a new project. Right now by default it's over here. Again, I will go to my courses, rendering, 2013, and I'll call it layer experiments. Alright, so we have over here the output. Make sure that you import the image, Control I to import. Let me go to my bookmarks so that I can easily access my images. And here we have like the home assignment. Let's see, the date is correct. Let me just add this one, import. So we see it's also 5 megabyte file. Let's connect it over here and let's examine what the problem might be. And the problem will arise the moment you will do some heavy color changes. So middle mouse button click, and what we're going to do is we're going to use some color correction, and we're going to use the color correction histogram. Drop the node on the wire, and so it gets automatically connected. And so what I'm going to do is I'm going to add much more contrast, and as you will see, the more contrast I'm adding over here, the more banding will appear. So we see that over here on the background, this is not like a very smooth transition anymore. We see like this very rough transition in colors. So that's why it is important actually to have like enough bit depth depending on what you're doing. And we see it over here as well. We see these problems arising in this clothing. So you clearly can see the banding showing up. And also over here at the foot of the chalice, if we make this just a little bit more extreme, again over here you clearly see the banding appearing. So what we're going to do now is we're going to try and find a solution to that. So go back to your Autodesk Maya, go back to your render settings, and like I said, it's over here in quality, going down to the frame buffer where you can change. So right now, like I said, 4 times 8 bits, so 4 times 256 colors. So if you're going to make this better, we can choose about between these ones. You have over here floating point short with half and with float. So short actually is over here integer. It's not floating point, this is integer. So the real ones to use is actually the float and the half. This is the floating value, 32-bit is by default, and because it's here 16-bit, that's why they call it the half of the float. So let's start with this one, and let's close this again, so make sure that it's being changed. Go over here to render, again batch render the thing. It's re-rendering with mental ray. See it re-rendering again. Done. Go back over here. So once we update over here the result of the home assignment, which we can do right here, you have like the reload button, then you see right here it has much improved already. Everything has become much smoother. But it's still not perfect, especially if we're gonna look over here at this region. So if we're gonna make it like really sharp right over here, you can still see that we do have a lot of banding. So depending on the amount of control that you want to have, depending on the accuracy, you still want to make this a little bit higher. So let us go back to Maya. Let's do a last one. In this case, let's go to a 32-bit. Now remember, 32-bit is a much bigger image, so it takes much more memory, and it takes also a little bit longer to write the image. Okay, so let's do this again. Render, batch render, wait while we see the result being built over here. again check the problem we had over here. If you go to home assignment and we reload again, then also over here that problem has been solved. So this is basically solving all these kind of issues. Now you might think, I'm not sure whether it's going to display very well on the recording, but over here you might see some strange pixels appearing. Now the reason why this is still there has to do a little bit with anti-aliasing. So if you want to solve that problem as well, we can go over here and change the quality. Instead of using adaptive sampling, use fixed sampling, so it uses 1 pixel exactly for everything. So like that is going to be pixel perfect at least. So that's the last time we're going to render batch. And let's update this over here, reload, and like this we see the problem has disappeared over here as well. So that's basically it for all the controls. Gives you right now all the proper render settings and everything what you need. Okay, so this concludes the very first part. In the next part we're going to check the render passes themselves.